Good morning, afternoon to all participants. It is my pleasure to welcome you to the Future of Remotization in the Electric Power Industry webinar. First of all, I would like to thank everyone for squeezing the time for joining us today. In today's webinar, we will be presenting the contents of the white paper produced by the GSAP members. During today's webinar, our experts will share the importance of remotization and reliance of various new technologies that will contribute to the adaptation of utilities to the new economic realities and constraints related to the shift from today's carbon-based economy towards a green and sustainable carbon-free economy. Before starting with the presentation, I will invite Mr. Duval, GSAP Executive Director, to give a welcome remark.
Thank you, Luis, and good morning or afternoon to you all. So it's a pleasure to be here with you. My name is Vincent Michel Duval. I'm the Executive Director of the GSAP. Sustainable transition and digitalization are key discussion in today's energy sector. These discussions are about how to evolve the current energy utilities. They are also about how to transform the way we produce electricity, but as well the way we use it in order to maximize utilities' impact on climate change and on GHG. While physical distance has traditionally been the main barrier for global service, while COVID might have shown us that we can do a whole lot from our living room, the reality for global energy providers is, to say the least, a bit more complex. Thus, energy providers are rapidly incorporating remotization directives in technology and communication services. Remotization has potential application in almost every sector of utility businesses, from generation plants to transmission line, distribution grid, and finally, client premises. It is thus a great honor and privilege for GSAP to hold this webinar on remotization. But before I leave you in the good hands of our global expert from AP, NL, and Hydro-Québec, please let me tell you a bit more about GSAP. GSAP is a unique CEO-led alliance of leading global electricity company promoting electrification and sustainable energy development. We are playing an active role in addressing global electricity issues, and we are engaging global debates on electricity-related matters, as well as providing information and expertise on the efficient generation and use of electricities. Our members are world-class electric utility companies that are leading the energy transition. Finally, combined, these members represent an unparalleled level of expertise as well as a global reach. I won't go through all of those numbers, but I do believe they speak by themselves. Thank you so much for being here, and I hope you enjoyed this webinar. Have a great day.
Thank you, Monsieur Duval. Before starting with the presentation, I will please request the participants to type their questions. They will be addressed at the end of the presentation. This morning, our panel is composed of experts from 3 GSAP member companies, Hydro-Québec, NL, and American Electric Power. From Hydro-Québec, Mr. Eric Dumont and Mr. Mathieu Monfron. Mr. Dumont is a senior advisor at Hydro-Québec with more than 25 years of experience and has worked as a researcher in the field of energy of end users. Mr. Monfron is a researcher in the robotics group at Hydro-Québec Research Institute. He specializes in mechanical conception, kinematic simulation, and project management. From NL, Mr. Sergio Gambacorta and Mr. Matteo Cantu. Mr. Gambacorta is a manager with more than 15 years of experience in ideation, design, and development of digital solutions. He's in charge of NLX Smart City Innovation Competence Center with main responsibilities linked to smart city technological scouting and new products setup and validation. Mr. Cantu currently leads Industry 4.0 inside the global power generation scouting and developing solutions in the field of artificial intelligence, advanced robotics to increase competitiveness, safety, and sustainability. From American Electric Power, Mr. Brady Johnson. Mr. Johnson is the manager of the transmission system and asset monitoring team at AEP. Without further ado, I would like to welcome our experts to start the presentation. Please, Mr. Dumont, I give you the floor.
Thank you, Louis, and thank you, Vincent, for this introduction. So this presentation aims at briefly present the content of the white paper. Obviously, there's more information in the paper, so I invite you to refer to the paper to have more complete information. But as Louis mentioned, you can have some question in the question box, and we'll try to address those questions at the end of this presentation. So that will be a quick overview of the paper. The art of the presentation today will be about the use cases. But in few words, I want to place the context of this of those remotization technology that we'd like to introduce to you today. So it's important to understand that, well, the electric system is already a critical part of modern economy infrastructure, but we think at within the community that the today's concern regarding greenhouse gas emission will put much more pressure on the system, as we expect that a cleaner generation mix with wind and solar generation major penetration that we can see already in some country, but we think that we spread all around the world, will make electricity the most valuable energy vector for the future. So we see a lot of challenge and movement for an industry which has not been very well, which has been very conservative for quite a long time now. So from one side, we see an increased demand as electricity will replace fossil fuel for many end users, according that the electricity will be a cleaner vector of energy. And as variable generation takes more and more place, flexibility will be the key to face this increasing demand without spending to limit the investment required to face this demand increasing. And to get this flexibility, we will count on distributed generation and other distributed energy resources as demand responses and batteries. We see a lot of new actors that will be part of this game, so electricity will need to manage a lot more interaction that will be much more complicated than the typical generation, transmission, distribution, energy pathway that we see in most jurisdictions today. It will be important for us to put our customer at the center of the system, as a large part of the flexibility may come from the end users, and we need to find a bring to bring them on board with us. And all those changes towards a modern system will need to be built on legacy components that may still be there for 25 to 40 years. So that's a real challenge, and that's where the remotization can help to overcome this challenge. Next slide, please. So what is remotization? Remotization can be defined as any means that allow to be aware and or act at a distance of a device or an equipment. And when I say distance, it may be 1,000 of kilometers or just enough distance to be safe from an injury. So there are many potential applications, and we see that some are already commonly in use, but we'll go further in the potential application. So we can go to the next slide, please. SCADA system is a well-known remotization technology already in application, but as telecom technology and sensor cost decrease and new artificial intelligence capacity increase, we can see many new potential applications. You can see some of those applications on the slide here, but obviously there are more data in the paper, but it's important to see the potential benefit that we can get from this remotization. And we're talking especially about increase worker and public safety, as example with early detection of potential hazard, or avoiding a worker to be exposed to potential danger. We can expect environmental benefit also by reducing crew traveling and limit those travel to tasks where they will need to act, not just inspect, for example. But we can see also environmental benefits by early warning of abnormal situation of an equipment that may represent a risk, like an like an oil leak, for example. Both system reliability and operational efficiency may be improved by a better knowledge of equipment wear and able to act before failure or postpone a maintenance if not required. That will bring reliability in the system. And we can see also robots and drones to allow to reduce maintenance time and simplify those tasks. So if you look at the next slide, we will just a quick overview of the drivers. Next slide, please. Yes. We can see technological drivers that allow further remotization. For sure, telecommunication deployment like 5G, and in the years to come will make it easier to adopt remotization technologies. Artificial intelligence also development is an important driver. Increasing computing power, data storage density, cloud solution, and a world of sensor, all of that at low cost would help to realize the remotization. And we can see also cutting edge solution availability and simple to use and implement in our operation that will bring remotization the solution of the future. So all that in the context that electric utility will need to improve the efficiency in a context to face challenges previously exposed. However, there are some barriers that we can see that remains a complex, still a complex IT environment, and cybersecurity may also be a concern. Budget are significant to do this change. Electric utilities are not in front of the pack, I would say, regarding the digital maturity. That's variable from one jurisdiction to other, but many places we are more pole and wire businesses than IT businesses, and that will need to be improved. We need to develop new skill and a cultural growth of our workforce. And we need to face the perception that some people may feel that they're being replaced by technology in place of seeing an opportunity to contribute to a more value added task. The fact also that electricity utilities need to deal with a lot of local laws that bring too many constraints may complicate the development of product which may be applicable to different markets. The next slide, please. The other point is the remotization won't be realized by electric power industry alone. That will need all the ecosystem contribution to get this remotization successful. So that starts from the opportunity identification and idea generation to solution development and industrialization, and for sure the deployment within utility. During the entire process, we need to work with the final users to ensure that the adoption and the will be possible of those technology, and that usability would be up to the point which is expected. And for sure, the cybersecurity and health safety will be important to consider, and those departments will be need to be involved to mitigate risk and ensure compliances. But there's a lot of room to different actors to help us, from manufacturer, technology vendor, university, labs, and for sure supplier to bring those equipment within our utility. And we'll need also the regulators and government to be on board to help us to modernize our infrastructure. The next point will be the use cases that we share in the paper. So next slide, please. So we're going through different use cases that has been already deployed in different countries. We will see different kind of remotization. The first is about, if we go to the next slide, please, is about a robot used to assess the durability of aging aluminum conductor. So that's a robot which is lightweight, simple to use, and use eddy current to assess the amount of zinc within a conductor, just to be able to evaluate the remaining life of the conductor. So this robot can be this probe can be mounted on a robot on the line. So if you can bring the other slide, please. You can see here an application of this probe on a robot used on a line that allow to assess the remaining life of the line. This replaces the usual way of doing things, which will be to cut and analyze samples from the line to see if there is some wear within the conductor. There's many benefits to use this technology, this remotization technology, instead of using only samples. Well, it allows to access the entire length of the conductor, not just a small length. It avoids to cut and add splices on the line, which is something which is splices are sometimes subject to aging, so you want to avoid those as much as possible. And by using this probe with a robot, you don't have to add those splices on the line. Obviously, it's safer because you don't have to remove the power, and well, you can just use the robots and avoid to have the worker involved with dangerous manipulation of the conductor. And it also allows to access very difficult area. In the example that you see, actually, you can see that over a river, for example, could be very difficult to access those parts. And using a robot, you may have access to this part. So all the information that you get from this sensor may allow you to postpone some replacement. You will only have to replace the conductor where it's really needed to do, and so it may avoid costly investment or report them in time. In the context of, as I said, that we will need to invest a lot of money in our infrastructure to face this energy transition, to limit those investment only to the place where we really need to do that. That's a real benefit. If we go to the next use cases, that's about the use of a drone. My colleague Mathieu is not here for this part of the presentation, but he should be there at the end if there is question regarding this use case. So this use case is about a drone able to land and travel on energized conductor. So that's a new technology under development, actually. A drone that can go on the conductor up to 315 kilovolts, energized conductor with amps, real amps on it, and that can carry different kind of probe to assess different information on the line. It could be about aging, could be about the conductor performance, and which is remotely operated from the ground. So line drone can land on energized conductor and then use a motorized wheel to travel on it and make a different measurement on the conductor. This technology is about to be commercialized thanks to a partnership. And if we go on the next slide, we can see some very good benefits using such a technology. We already did over 400 measurements with this drone, especially regarding the electrical resistance of transmission line splices. So we can obviously see the advantage of using this technology while we don't have to climb and you have no worker in proximity of energized lines. There's a ease of deployment as only 2 operators are required to operate the drone, and there's no impact on transit capacity. as the network operator doesn't have to put in place special safeties. And in the context that we rely more and more and on electricity for our energy for the customer, that's an important part of our business, to be able to provide a constant quality of energy to our customer. Obviously, it's also much quick to do the inspection, as only a few minutes are required to complete the measurement. And again, it also it allows you to access the hard to reach areas, such and avoid to climb on the tower or to use a bucket truck and stuff rough terrain. So that's an advantage of this remotization technology. So we'll go on with other use cases. Our next presenter will be Sergio Gambagorta from NL. So Sergio.
Hi, everybody. Here we were facing a very important challenge for the electric industry, because in these use cases, we addressed a typical action that we do when we manage public lighting. This typical action is the census. So as you probably know, it's very important to have the location of lighting posts, and also to know what are the technical features of lighting posts in order to address the maintenance, in order to work appropriately also in terms of upgrade of the lighting plans. And sometimes this kind of information, when you acquire a new lighting plans, or when you have let's say, new construction to be done in a specific city, are not widely available. For this matter, in order to boost the operation and maintenance activity, and particularly the census activity, we leverage on this new technology by addressing the public lighting census with the satellite imagery analysis. So basically, what we have done is to collect satellite images, but from day satellite as well as night satellite, in order to have a picture of what is happening within the city and where are the infrastructure. Because as you know, it's very difficult to detect a lighting post just from their specific shape, while it could be more effective to work also on the light that they are producing during night hours. And this is why we combine these two different satellite images. And then after this step, we addressed the recognition by correlating the specific cartography also with the geometry of lighting plans. That even if we don't know exactly how public lighting is planned in a city that we are not managing, we know what are the typical regulation. At the same time, we worked with the machine learning at first time with the not supervised model, and after collecting several records, we addressed the supervised model. In this way, we have been able to boost efficiency and effectiveness of this task. Because take into account what are the traditional tools that, as usual, are used in this kind of task. We estimated that we can save around 75% of operational cost compared to solution like the home field workforce or also Google Car-like solution. At the same time, we saved also time, because we analyzed the previous performance, and we detected that we can achieve up to 89% of time saving, because during the pilot stage, for example, we addressed more than 100,000 lighting pole census in 12 weeks. in 3 different cities, in 3 different nations, because it was Pescara in Italy, Móstoles in Spain, and Puente Alto in Chile. And so basically, thanks to this innovation, we were very, very happy because we were able also to contribute in a specific time period that was affected by pandemic to safety. Because thanks to this innovation, we reduced the on-field activity of the workforce for the light sensors, and we are being able also to increase the quality of services for the city, because thanks to the brightness correlation, because we have defined a range that go from level 1 to level 250, we were able to qualify the correlation between the brightness of a specific district and the population density, in order to detect what are the district of a city that, even if are very populated, have no enough light for their needs. And so basically, this was another key benefit of the project, that after the POC stage has been fully scaled and is currently used in NLX to address the lighting sensors. I would like to pass to Matteo, always from NL, for next use cases.
Thank you, Sergio. Hi, everybody. Okay, this use case deals with the use of artificial intelligence and algorithms to identify risky situations and behaviors in our construction sites as well as power plants. We, as Enel Green Power, have an important pipeline of projects that are mostly related in these years to the development of new photovoltaic and wind capacity, meaning that we constantly have our construction sites in places where we are remote. So we have troubles with connectivity issues, and we are dealing with huge spaces, meaning that with the current process that is available to ensure safety, that is a human supervisor walking around and making sure that all the safety rules are respected, we cannot be fully efficient in detecting and in preventing all the risks that may occur, even though, of course, we push a lot as a company on policies and on procedures in order to respect the safety issues. So the idea that came out was the one to use computer vision algorithms based on fixed cameras that are installed in the place where the daily works are carried out, in order to support or potentially in a longer time period substitute the operator, the safety supervisor, to increase the rate of detection of troubles. Which are the risky situations that we are speaking about? You can see some examples on the left part of the chart. It could deal with the delimitation of areas, so where people should or should not stay. It could be an interference with viability. For example, if some object is left in between some area where it should not be, or for example, the proper use of personal protective equipment. This is not an exhaustive list. We identified more than 30, and we are training our algorithms in order to identify this kind of situations or say risky behaviors. The system that is currently in its final phase of testing, and if successful, will be scaled on a wide set of our construction sites, and afterwards might also be scaled to our power plants for operation purposes, is capable of sending a real-time notification to the site supervisor, as well as to provide, as long as the connectivity allows it, also a key message to the central safety team, in order to notify what is going on in terms of wrong procedure risk behaviors, and intercept in time this kind of risk. The system is currently aimed at running on a local CPU, but of course, whenever the connectivity is available, it also provides a backbone connectivity toward the central system in order to upgrade the system, for example, retraining of the algorithms, or either to collect the statistics that then become an important basis of digitalization for the company to know what exactly is happening at our sites. So eventually, the benefits that we are getting out of this are, of course, to encourage the people to act in a safer way, because they get a feedback on their behaviors, to increase the number, and we expect that we might increase at least 50% of these detections of risky behaviors before they occur. Of course, a faster intervention in case the risk are happening, and by collecting statistics and digitizing everything, of course, we aim at understanding which is the best mitigation strategy for each use case. This is all from my side, and I guess that the next speaker is from AAP.
Hello, thanks. So yes, I'm Brady Johnson, the manager of the transmission system asset monitoring team. Here I'll talk to you about basically our monitoring strategy of our large transmission level substation power assets. So what that real-time monitoring looks like is basically, it started with AEP kicking off a new initiative to gain a further, deeper understanding of our EHV transformers and transmission level transformers, transmission level reactors. And to do that, they came up with a new team called Asset Health Team, and so which has now evolved to the transmission system asset monitoring, as our work has also evolved with this. So initially, as they were looking to kick this system off, look at real-time monitoring of those assets. And what that team did was go out and have to look at what is possible to be monitored on the various assets versus what are the monitoring capabilities of the equipment that's actually out on the market. And then we had to decide, do we really want to catch fast acting failures versus slow acting failures? What other aspects are the actual monitoring, like partial discharge, electrical versus UHF, bushing health monitoring, temperature type monitoring, dissolved gas analysis, and such. And then those sensors all have their abilities. So some will catch fast acting, some will catch slower acting, and then so kind of meshing those together to really form a standard package that'll be a jack of all trades, but not really specialized in either one, to kind of have an overall blanket over the assets. And the key here was also having remote connectivity to our equipment. This gives AEP the ability, and my team the ability, to do firmware updates, software updates, remote troubleshooting of the monitoring equipment, remote ability to log in and plot or trend data depending on the circumstances or what we want to do. But really having that remote capability into that equipment is key, because we want to also provide and install a low maintenance piece of equipment, right? So we're not trying to add any extra maintenance to our operations folks or our field folks. And so with that development of the standard monitoring package, then the Asset Health team has then moved into that deployment phase of getting it blanketed out across the entire AP footprint, which we've got a little over 400 of our assets with that standard monitoring package deployed on and installed. So with that, as we're moving out of that deployment phase and that's completing up, then we're really kind of moving into that near-time notifications. So with the alarms and data, what do you do? What is that next steps? And really, what are the benefits of creating those next steps around it? And obviously, safety is first and foremost. So TSAM can remote into that monitoring equipment. We can verify that health in real time, right? So it's really looking at your Apple Watch or Fitbit, collecting that real time data, understanding its current health, and then letting the person that's working in maybe a confined space or near an asset, or they're going to be out there for maybe 6 months working on a project, just ensuring them with our ability to log in remotely and look at that data, we can kind of give them that blanket of, yeah, here's the current health based on that real-time data. You're fine to work in that location, or no, we maybe need to create a virtual barrier and you stay away by so many feet, or no, actually get away from the asset, don't go near it. We see elevated values that are in our alarm thresholds that have met those alarm thresholds, and we actually really need to be taking a next steps to looking at what do we do with the equipment. Also, that's really helping with that remote initiative, and remote capabilities really helps eliminate the need for like a manual aura sample, right? So if you do have an asset that may be heading toward catastrophic failure, you're not sending someone to site to be right up against the asset to collect the manual oil sample while you're actually seeing, while it could potentially, catastrophically fail. So you're helping with that safety as well. And then obviously it really leads to less drive time. So now you're handing the folks a laptop to log in and look at it and do their work instead of just jumping in the truck, heading to site, and then trying to figure out what's going on with the asset visually. So really huge improvements around employee safety. And that's always first and foremost, right? And then moving into like the condition data and actual alarms. So now that you've got all of that, because we've got the real-time alarming, you've got the real-time notifications and that real-time data coming in. So now we know the actual condition, and we can potentially prevent unplanned failures and the collateral damage that goes with it, right? So as we get the data back in via SCADA, those alarms and analog values will go into our operations. We get notified, and then we come together collectively. So this is a collective approach through AEP, right? So everybody brings their knowledge to the table. We make those decisions on should we remotely remove that equipment in that controlled manner, or should we watch it a little bit longer and let's see what happens based on some of our lessons learned and looking at the data, which I'll get into a little bit later. So we can leverage all of that data to make those real-time decisions. You can also leverage that data as well to make longer decisions, right? Longer data-driven decisions, which really kind of gets into that that condition-based maintenance and condition-based renewal, where those folks are able then to look at a place, find its actual asset health score using one of our softwares that we have, and when they're looking to renew, should they be really looking at time-based, or should they be really kind of looking to that condition-based? And now that we've got that real-time data, we can help kind of push that work toward that condition-based based on the actual data. And so, maybe you don't need to work on a system that's 35 years old. You actually have a transformer here that's 25 that may be in worse health, and then let's go find out why, and does it really renewed? Same thing with like the maintenance activities. You're using that data to really kind of drive those next steps. And so when we're looking at maintenance, that's the actual maintenance itself or inspections. You're going from that time base to looking at an asset based on its scoring, looking at the long-term score. How has that score gone up or down based on activities, or what's going on with the actual health of the system, and then making those data-driven decisions, and then potentially moving those, expanding those maintenance activities out, right? So we're extending those durations based on, do you have multiple gas units that are looking at the same thing, that are doing that checks and balance, so you feel safe enough and you can justify why maybe instead of doing something 6 months, we can push it out to every year, because we've got that real-time data coming in, because we've got it come to our alarms, and other folks are making those decisions, looking at that data and figuring out what to do with it. And then obviously the increased awareness in real-time systems. So it's just another data point. It's actually a lot of data points coming in, right? That you can apply with other aspects and other data that's also going on with the grid, and to make a whole decision, right? So can you correlate weather? Can you correlate power quality or the PMU data all together to kind of paint the whole picture of the actual status of the entire grid? So it's really providing extra insight and data into that. And then getting into the lessons learned. So there's three major bullets here: really ensuring the monitor equipment's installed and commissioned, learning how to interpret that data, and then clearly defining those roles. They really all go hand in hand. When we're talking about the ensuring the monitoring commission, ensuring that the actual equipment is commissioned prior to energization. So we learned, we had a hard lesson learned that our equipment was actually installed on a unit, but we know you have the bathtub curve for transformers reactors, right? So as in that very beginning state, there's potential there for them to fail. And then as they get a little bit older, then they go down and become much more reliable. And then as they get older, then they're a little bit prone to fail again. And so from our lessons learned, what we've seen in the past is we had units that actually catastrophically failed right during the energization there, and our monitor equipment was installed, but the alarms weren't going back to operation. So it was a hard lesson learned. Our equipment did pick it up. It sent off the alarms, but the alarms weren't going anywhere. So we had no idea, right? And no one was informed, and we could have prevented that. We actually gained a known signature from that, and we took that and added it as our lessons learned, right? So getting down into then how do you interpret that data? So now that you may have had that lesson learned, or you've got other lessons learned where we weren't able to prevent a catastrophic failure, but as the asset was quickly going and deteriorating, we saw the data, we were able to learn from that data and then apply that data and apply that knowledge to our standard package and really kind of hone in that standard package like I was discussing above, and using some of those lessons learned to really figure out what is our equipment good at, and then where does it actually need to be short at, and what are those next steps to proceed forward. And so then hopefully we'll get into applying automated analytics. That's really that next steps of deciding, can we predictive and see like an asset's actually deteriorating quickly? Can we get on that predictive scale and say maybe you have 3 to 6 months and really kind of help drive some next decisions based on that data that we're seeing and known signatures in the past, and kind of leveraging that in the future, or hey, we see this one that could potentially be failing here in the next few hours or next few days, based on here's a lot of our lessons learned prior to, and we add that to all that data to make the knowledge. And then clearly defining roles and responsibilities, right? So you have a brand new team, you have a new team that's applying new equipment out in the field, you have new alarms coming back to operations. And so these projects touch basically every department inside AEP, really, to project managers, to the P&C folks, to your operations. And so, who does what, when, and where? And then how do you respond to ensuring and making those next step decisions. So we had to create quite a few guides and really work with the various SMEs and work with the other departments to make that determination of, where does your swim lane start and stop? And then how does this all fit in the grand scheme of things, and how do we all work collectively together to make quick decisions? And I do emphasize that, specifically when we do take a system out, it's not my team saying, hey, we should take this system out. It's actually us providing the data to the various SMEs. And then they use that knowledge and information gained to really determine that next step. And so it'll be really great to see where AP can leverage more of this data here in the future and really kind of head toward that condition-based maintenance activities, obviously with also condition-based renewal activities, and then also getting into that predictive analysis. And then also looking at other asset classes and types inside the substation that we can then monitor, and then just bring back that data to really fill in any other gaps that we may see. So that's what I've got. Thank you.
Thank you, Brady. It's again, Eric, I'm back just to conclude this presentation. Well, that's a very brief overview of the paper. So I invite you again to go on the GSAP website to access the paper, which is come from a collaboration of many utilities that in a very interesting collaboration. I want to thank every contributor to this paper. So we need to in conclusion, we need to remind that with new responsibility that will come to electric utility will keep the one to serve reliably, efficiently, and affordably our customers. That's very important to remember, and that's why remotization can become so important. By sharing this vision, we hope that we promote development of new technologies that will help to accomplish not only our today's mission, but the mission of tomorrow that will be that have some challenge. We have all the challenge in front of us, and that remotization can really help to address those challenges. We think that in order to succeed, we'll need to partner with a large number of partners from the ecosystem. So developers, manufacturers, suppliers, integrator, but especially regulators and government will need to be on board with us to allow us to move more quickly. And only such a collaboration may allow us to affordably expedite this evolution in order to overcome the challenge in front of us. So again, I want to thanks everybody, and to we stay within time, so that's good. Luis, if you want to share a question that has been raised by people.
Thank you, Eric. First of all, I would like to thank all the experts for their presentation. I will now start with the questions that we have received from participants. If there are other questions, I would please request them to be typed on the question and answer section. The first question that we have received is directed to NLX. The question goes, has NLX developed partnerships with satellite companies for the case study that was presented, or how have you proceeded with your case study?
Sure. Let's say that first of all, we have a very important partnership in place with the European Space Agency that we are leveraging also for our group innovation projects. But I'm happy to share that for these specific use cases, we follow a different path, because we published on our crowdsourcing portal, the Open Innovability portal, a challenge related to the public lighting operation and maintenance optimization. And we collected several answers from potential solvers, and a very interesting SME from an Italian contest answered, offering the collaboration of collecting from different sources and from different space satellite provider this kind of information, and help us with the first step of normalization. So in this specific case, we leveraged on this partnership. Even if I shared, often we collect directly satellite images, and most of them are from Sentinel Copernicus and from, let's say, open sources.
Thank you, Sergio.
You're welcome.
The second question is directed to Hydro-Quebec regarding the drone case study. Has Hydro-Quebec implemented a training center for drone operators now?
Perhaps I can answer. I don't know if you hear me.
Yes, we can hear.
Okay. So yes, all our pilots have to be advanced pilots, so they have to be able to operate drone in controlled airspace. First, they are following theoretical training, which is dispensed by a provider. Then for the practical training, we've got 3 people that are able to train our pilots. It's short for the practical training. And after this 1 to 2 days training, pilots have to practice for basic operations outside controlled space, etc. Then after, I would say 1 or 2 months, they come back, and our 3 people, are able to make the flight review and certificate them in the name of Transport Canada, I would say. That's how. We don't have really a training center, but we have people able to train to do the practical training, then to do the official flight review for Transport Canada.
Thank you, Matthew. I think this question is directed to everyone regarding security of the systems. How have you proceeded to secure yourselves to avoid getting hacked, since you now are interconnected? I don't know, Eric, if you can start with from Hydro-Quebec side and then move on into NL and then AEP.
Well, sure. Well, understand that we won't reveal here how we protect our system regarding cybersecurity, but yes, cybersecurity is a concern from start to finish, I would say, and we take into account this this need for protection from the beginning. I don't know if NL and AP would like to add something.
Yeah, I think so. Brady with AP having the remote capabilities to our equipment from our team gives us the ability to keep it updated, and that's why we're really focused on doing a lot of those firmware updates or software updates, so that way our system can be patched right remotely and done quickly, and then also ensuring like the various passwords and stuff like that to the equipment are also updated to something that AEP security team approves, and so no longer like using the vendor supplied passwords to the equipment also helps keep the system secure.
And that's pretty much the same for NL, like every kind of collaboration or setup or IoT device that we put in place is always approved by the dedicated cybersecurity team that double check this in advance. So we fully rely on a dedicated department of the company before any kind of deployment.
Perfect. I think those are all the questions we have received so far. Before closing the webinar, I would like to indicate that the presentation and the white paper are on our website that are indicated in the slide on your screens. The recording will also be available to all the participants. On behalf of the Global Sustainable Electricity Partnership, I would like to thank everyone for their participation. Please stay tuned for our upcoming activities. And again, I would like to thank to all the experts from Hydro-Quebec, NL, and AEP for their time on drafting the white paper and making themselves available to present the case studies today. Again, thank you very much, and it was a pleasure to have you with us.
Thank you to everybody. Thank you for your work also, Luis.
Thank you. Bye-bye.
Thank you. Thanks. Bye.
Thank you.